Mecha CNS Power Spring Design software provides the most advanced development capabilities available to the industry. This video summary will dive into some of the details of the program by demonstrating the design capabilities for some hypothetical requirements. The design parameters are as follows: 2 Newton meters minimum output torque required, 10 retraction turns above the minimum torque, a 20 millimeter minimum arbor size, and a minimum of 8,000 cycles are required. A conventional design will be considered first, and later an equivalent pre-stressed design will be achieved. In both cases, another goal is to minimize the material weight. To get started, some of the parameters need to be entered to roughly move the design toward the outputs required. 20 millimeters is entered for the arbor diameter. The housing diameter is increased. The material thickness is increased. And the length is adjusted to get the material that makes up the area filled close to 40%. Some notes on material thickness and width. A conventional spring typically gets its torque properties from a larger thickness as opposed to width. A pre-stressed spring typically uses a thinner gauge material with a wider width. Spring width can be easily adjusted to scale the torque, but availability, cost, and capabilities can sometimes present challenges. Also take note of the guidelines shown to the right. The percent fill, the length over thickness, and arbor diameter over thickness ratios are important to help steer this spring design. Next, the cycle life parameters are entered. 10 working turns are required, and the preload turns are set to achieve the minimum torque, in this case 2 Newton meters at 12 turns. This design now has an error because the working turns are out of range. By adjusting the material width, the preload turns are now 2 Newton meters at 5 turns, which brings the expected cycle life into range. 98% failure assurance is also selected, meaning that nearly all tests are expected to have better results than the predicted cycle life. Make note of the shape of the spring shown in the simulation. The visible dead turns tell a lot about the spring design efficiency. Too many dead turns are a sign of a high cycle life spring with gradually increasing torques. Very few dead turns are common to a spring that has lower cycles and a quickly increasing torque. Experience allows the user to adjust the design so that the dead turns match the design goals. By selecting a pre-coiled spring, the winding method is changed, retaining some of the material stresses and reducing the dead turns. In this design, it seems to be the right decision. Further enhancements of this design achieve the torque, turns, and cycles required. This design also allows some safety turns to avoid a fully wound condition that could reduce cycle life. To determine the specific point at which the torque is expected to meet 2 Newton meters, turns can be entered to interpolate the point value. This completes the conventional spring design. Note the weight of 0.65 kilograms. It will be used for comparison in the next design. Next, the pre-stressed spring type is selected, and immediately the torque is significantly higher. Typically, the advantage of a pre-stressed spring is a flatter torque curve. The challenge is to make the design meet the required cycles. To get closer to the torque required, the thickness is decreased, the width increased, which is common to a pre-stressed design. Again, review the dead turns shown in the simulation. It gives some indication about the torque and cycle performance. Since the cycles are lower than required, the free coil or shape of the coiled material before backwinding can be increased to reduce stress and improve cycle life. Each time the free coil is adjusted, the free turns also adjust to represent the new design. Further adjustments allow this design to meet the initial requirements. Keep in mind that pre-stressed springs can also benefit from using higher stress materials that can handle the higher stresses involved in pre-stressed springs. The final weight of this pre-stressed design is 0.56 kilograms for a savings of 0.09 kilograms per spring when compared to the conventional design. This can represent a significant savings based on material cost and margin. Thank you for taking the time to review this software in more detail. Please visit our website at www.spiral-spring.com for details on how to place an order.